Good morning, everyone. I am Kishan Shinde, pursuing my engineering 6th sem, third year in Sri Venkateshwara College of Engineering, Bangalore, in domain of computer science in engineering with artificial intelligence. This is my introduction. Let's jump into today's topic, that is factors affecting energy resource development. What is energy resource development? Energy resource development refers to a process of creating, implementing, and improving the technology and infrastructure required to extract and produce and distribute energy resources. That means it is a process where creation and implementation and improvising the technology which requires to extract, produce, and distribute the energy resources. This process can include exploration and drilling of oil and gas, building and operating power plants for electricity generation, and constructing pipelines or transmission lines for energy transport. Energy resource development can have environment and social impacts and requires careful planning and management and regulation to ensure sustainable and responsible use of resources. Factors affecting energy resource development. There are five basic factors that is affecting the energy resource development. That is fuel substitution or scale of shift, energy density, power density, intermittency, geographical energy distribution. Let's see what are all these factors that are affecting energy resources one by one. Firstly, fuel substitution or scale of shift. Fuel substitution refers to a process of replacing one type of fuel with another for energy production or consumption. This means that we we replace a type of a fuel with another type, which could be anything. Example, a wind, which is replaced by sun energy, or what, or fossil fuels is replaced by solar energy. This is known as fuel substitution. For example, switching from fossil fuels to renewable energy resources such as wind or solar power energy. Just how I said it. The scale of shift can depend on factors such as cost, availability of resources, technological advancement, and government policies or incentives. A larger scale of shift towards renewable energy resources is generally seen as a crucial step in reducing greenhouse gas emission and mitigating the effects of climatic change. The scale of shift can depend on factors like cost, availability of resources, technological advancement, and government policies. Which means that the cost which is incurred on the shift of these fuel substitution is one of the factor, and the availability of resources. If we are shifting from renewable to non-renewable sources, then the availability of resources of non-renewable energy should be more, because as we shift there, the if there is no availability, we can't use it. So, and technological advancement, there should be technology such that we could use renewable energy. For example, as of today, solar energy could not be used completely to its full potential. There is no technology yet which uses the solar energy completely. As years goes on, the technology keeps on advancing. The energy consumptions and energy utility could be done in efficiently, more efficiently, and most importantly, government policies and incentives, which means that government should promote and provide funds to develop these kind of technology. A larger scale shift towards renewable energy sources is generally seen as a crucial step in reducing greenhouse gas emissions and mitigating the factors affecting climatic change. So there is a larger scale of shift towards renewable energy resources. That means that there is a larger tendency to shift to renewable energy resources because it has its own advantages. That is, it reduces the greenhouse emission gases, which protects from, which prevents from harming the ozone layer or any as such, which can make global warming. And Yeah, uh, it can also reduce the affecting of climatic change. Nowadays, the climatic change has been intense due to greenhouse gases and lot of emissions from non-renewable energy. These could be controlled. Next, energy density. Energy density refers to the amount of energy stored in a given volume or a mass of particular fuel or energy resources. It defines the amount of energy stored in a given volume or a mass of particular fuel or energy resources. The higher energy density, the more energy can be stored per unit of volume or mass. The more energy we, the more energy density, the more energy stored in a volume. Amount of energy contained in a unit of material object. SI unit of energy density is joules per meter cube. Power density. Power density refers to the amount of power output per unit of volume of or mass of a particular power source. The higher the power density, the more power can be produced per unit or volume. Same as the same as the previous thing, energy density. The same thing goes to power density. That is storing a amount of power per unit volume or a mass of a particular power source. The more the power per unit, the more the power can be produced per unit of a mass or a volume. Power density is an important consideration for many applications, particularly those with limited space or weight restrictions, such as transportation or portable electronics. For example, a battery with high power density can store more energy per unit weight and can power a device for longer of periods, which means a battery with higher power density, that is, nowadays we see portable chargers, that is, the charging devices which can be taken from wherever you want. Those devices having more power density stores more energy in it such that it can charge the phones or your devices for a longer period of time. The SI unit of power density is watt per meter square. Intermittency. Intermittency refers to the variability or unpredictability of energy output from certain renewable energy resources such as wind or solar energy. Let me read it once again. Intermittency refers to variability or unpredictability of energy output from certain renewable energy sources such as wind and solar. This means that the variation or unprediction of the energy output from certain energy resources, that is wind or solar energy. Solar energy or wind energy is never constant. There is no days that every day the solar energy or wind energy being constant, as that is a natural calamities or natural energies. It could be very lot of variation. There is no energy which can perform give its best. Energy output from these sources can fluctuate due to weather patterns or other external factors. Intermittency can pose challenges for energy grid operators who must ensure that a balance between supply and demand at all times. As the sentence says its own all the meaning. Intermittency possesses challenge of energy grid operators. What is this challenge is that it should ensure the balance between supply and demand all the time. When energy supply is inconsistent, it leads to issues such as blackouts or brownouts. Wind or solar energy are intermittent. Next one. Geographical energy distribution. Geographical energy distribution refers to the uneven distribution of energy resources across different regions of the world. There is no energy or energy geographical energy distribution says that there is no energy that is being distributed all over the world uniformly. It's always uneven. Some place the energy is more, some place energy is less. For example, if you go to hill, hillside, you might find more wind. Or if you go to a low lying area, there might not be a lot of wind as an hilly region. So these windmills are being situated in an hilly regions where where wind is more, such a way that geographical distributions defines this. Some regions have abundant access to certain energy resources, while others may have limited or no access. The example I gave it is windmill. Energy resource such as solar energy or wind energy have potential to reduce impact on geographical energy distribution by providing access to energy in regions with limited access to traditional energy resources. However, the practicality of this approach depends on factors such as local climate or geography, as well as the availability of technology and investment. Thank you. This is it.